Hi, everyone. Welcome to Data Engineering Weekly Radio. We are here to talk about edition 133. As usual, Ashwin with us here. Ashwin.
Hi, everyone. Hopefully, you're all doing good and great.
Yeah, awesome. Ashwin, so on 133, what are we going to do? We're going to talk about LakeFs wrote an interesting article about a Write-Audit-Publish pattern. I think this is something that a lot of people are talking about it, and even data engineering usually,
We have spoken, I think, right? So on that web.
Yeah, and the emerging of LakeFs architectures kind of well adopting this kind of strategies. I also write about the WAP patterns, one phase and two phase commit strategies that different systems are using there. And we're going to jump on vector databases, the concepts and examples. Vector database is kind of very powerful, this tremendous investment is going on in the vector database spaces. So the article just really go through like what is the concept and what the examples are behind that and some of the use cases behind vector databases. The last thing that will be end up with data warehouse testing strategy for better data quality. We're always passionate about data quality, and it'll be interesting to see how.
I think it's a pattern now, right? So there's a lot of similarities between a lot of our conversations, but I think it only reiterates the problem that you're facing and the problems that data teams also face, right? So we end with quality, but then to have better quality, what if you have a better WAP framework in place? What if you have better structures in place, right? So and again, vector DBs are going to be interesting. So today I'm going to take a lot of Anand's brains because he's got great implementation experience around each of this. Let's jump on to WAP now. I think that's a topic we covered earlier as well around the Write-Audit-Publish pattern. I like this blog for a particular reason because it covers implementation patterns not just for open table formats. It also covers it for traditional RDBMS as well, right? So that's something that has traditionally been missing because it's not native support here, right? So like Hoodie or Iceberg, where there are implementation patterns, RDBMS continues to be a storage area and continues to be used in a lot of enterprises. So I like the blog for that. Right. So what are your thoughts on this? I think
the article is kind of goes like very in depth about the general WAP patterns, and then LakeFs itself is kind of supporting a versioning of all of this, right? So the blog essentially talks about like how Apache Hui and like Apache Iceberg and Delta Lake is kind of essentially support these formats. By far, I like the way Iceberg is supported. You just need to enable the WAP flag, and then interestingly, all three different formats support WAP pattern in a very different way, right? Apache Iceberg, for example, has a very solid support. For example, you can say like WAP flag is enabled, and then you can write your own data validation checks after that. And if the validation check is failed, it will not get published. So all you need to do is to set your table property as the write.wrap.enabled equal to true, and in the spot configuration or in your table properties, it totally works, which is kind of very good. The Apache Hudi, on the other hand, has something called pre-commit validator. So before you commit the code, like all those LakeFs codes are working in the concept, right? Like just imagine if you're not able to envision, just imagine your Git flow. All the way how GitHub works. When the Apache Hudi data lake, all of things, also the LakeFs is working in a way that you're writing a new data set. Essentially, you're creating a pull request.
Yeah.
And then you are merging that into a main branch, which is essentially the versioning concept of data works. So assuming that you are running a hourly job, so instead of writing directly into your main branch, which is like you are just writing into a temporary space, assuming that as a pull request model, right? So in Iceberg, you can just enable the flag and assuming that it's create a pull request, and then you're running a data quality check. And if a data quality check is failing, it will not merge. So your data still exists in your own separate branch kind of thing, and it will not do that particular part of it.
Got it. Got it. So
Who do
among
you,
all that, Iceberg seems to be the more robust
yeah,
approach, right? And the more easier approach
yeah,
from an overall perspective.
yeah. Hoodie, on the other hand, I think they have this concept called pre-commit validator. So imagine that you're just directly committing that into your main branch, and
Yeah.
then commit validator essentially validate your checks, like you can write your data quality check. And if the data quality fail, it will not come in, just roll back for you. So that, I mean, it's pretty good. The disadvantages with this approach is that, let's say a write fail, data quality check is failing. The block rightly called it out, like, I wanted to profile further and see like why it is failed, what data issues that it
Right.
has. And that is kind of a challenging here. Delta Lake, on the other hand, it's what Delta Lake and Snowflake in a way, they all do what I call like a two-phase commit in the WAP. It's just like a shallow copy. So before you writing that into, imagine that you're committing a code. Before you're writing that, you have to call all your main branch to you, and you're adding a new data, and then commit everything together into a new file. So it's kind of a shallow copy publish model. Um,
Then with Snowflake, the approach is still not seamless. It's still the same approach as RDBMS, except that you're writing it into a temp zone, right?
Yeah, so it requires a lot of data shuffling and data write and stuff like that. So Delta Lake is, I hope Delta Lake will support kind of this kind of a transaction support.
Natively, like how Iceberg does, because with Iceberg it becomes very easy. You enable a flag. If it is
Yeah,
fails, then it fails. The data may exist, but it's still not merged into your overall data branch.
right. There are a couple of other interesting projects to watch out, like LakeFs is obviously one thing. You kind of natively support the branching strategy, which is essentially write, audit, publish model. Like, when you're writing, you're creating a new pull request, and then assuming that CI/CD pipeline, like your GitHub actions are running, which is auditing, and then, oh, okay, it's all fine, you're merging.
Yeah.
That's essentially that pattern, very similar to GitHub Flow. LakeFs is one system that is kind of implemented that one. Apache Nissi is another project. You can also look around that. It's a very interesting thing. But I'm hoping all this Lakehouse formats should or will support map patterns out of the box one way or other. And
There's nothing new here, right? So we have traditionally done this in the Oracle world as well, except that it has been done in a very traditional approach. There's a lot of labor involved.
right.
This becomes a native seamless fashion in the OpenDB
Yeah.
world.
Yeah, the older days we do that. What we do that we write into a staging layer. A staging layer is essentially, we are writing a temporary database, run
Yes.
through a data quality check, and everything is fine. Then we merge. Everything we have to manage by ourselves, like where we need to
Yes.
write it, and then we have to clean it up and everything. This is a pretty standard option because when you're creating new data sets, I believe it should be automated. I think,
Yes. Totally. Right. So in a DBMS world, that's one approach we did. And the author also talks about the partition-based approach, right? Because when you're writing audit, even if you're doing it for a full select, it's going to be very complex, right? Any select that you do. So you do it only on partition data. So you create a salted partition and then write the partition, then swap the partition. So you could pretty much do that. But then that's essentially was some of the approaches that we had tried in the past. But that's on RDBMS. Then lakehouses and lake file formats, I think it's largely a seamless, easy process.
right. Yeah, and yeah. So next subject, which is vector databases. Pretty hot subject, and there's a lot of conversation around should we really need a separate vector databases or not? Doing like what should a company should invest on? Should a company be investing on vector databases or should not? And what is the use case behind it? I think the blog is kind of very interesting take on vector databases. At least give the very basics and give an option store on that. Yeah,
But what do you think, so should companies invest in a vector DB or should the company not invest in a vector DB? I think we're just chatting prior to this call, right? So
yeah.
want to share some ideas about this?
As with any data questions, right, it always starts with it depends, right? So
Should I ask ChatGPT around?
yeah,
Should I use a vector DB?
here's my perspective, right? So should I invest in vector DB? It depends upon what is the use cases that you wanted to try. Let's say if your use case is some simple search and retrieval problem that I wanted to do an e-commerce catalog and I wanted to find my data, I think find my documentation, where exactly the words are exist, and I wanted to tune some relevancy and stuff like that. Your traditional, a typical text search engines are pretty good. Like any system that built on top of Lucene or any inverted index systems like Solar or Elasticsearch. On the other side, if you wanted to have the use cases like what the blog is kind of talked about, like a recommendation system, semantic search, anomaly detection, personalized marketing, like all sort of personalized and relevancy things. I think vector databases and vector search space is kind of very, very interesting.
I think anywhere where there's relevancy based search or match kind of a use case, is that right? Is that a fair point or?
Yeah, basically what it difference that, instead of using like what those vector databases doing that, they use a specific indexing techniques like KD trees or hierarchical, what the blocks is called about inverted multi-index to organize the vectors that we are creating, the feature vector that we are creating put it into the search space. So it's very easy or very efficient for these data structures to find the similar items, very small.
They're more like the indexes, right? So they're you can relate them to the indexes, articles.
Now, saying that the typical text search engines that you find, Elasticsearch and Solar, they do also support this kind of vector indexes. Right? Now, going back to the question, like should a company invest or not? Whatever, like not every vector database is created equally. Depends upon what kind of an indexing technique that they're using and how efficient it is, and what is the other operational efficiency that the databases are giving in. Operating Elasticsearch and Solar is not cheap. It's pretty expensive to do. Now, some of the systems like Pinecube or the Pinecone or the article is kind of talking about databases. These vector databases, some vector databases come GraphQL interface by default. So you just have this crude layer already available for you to kind of access that one. It's a typical DO layer for you to do that. So there's like minimizing the number of development cost on top of it. I think the other critical factor is like, if you take any businesses, operational data store is a primary data store for you. Like whether you're using your MySQL or Postgres, MongoDB, any other databases that you are introducing is an investment. Whether you are doing an Elasticsearch or whether you are doing another aspect, vector database alone, it's still going to be a separate database. So ask yourself, what is the use case that you are solving?
And what goes into the vector database is also very important, right? Not everything that's on MySQL. So you need to be having a right use case. So in a recommendation model or something, those set of data sets have context and what I call as relationship entities that make that search more. That context is more important in that particular use case, right? So that's why you need a vector DB. But if you're just searching for a match and there's no relevancy-based search that is required, I don't see a reason why to use a vector DB, right?
Yeah. I mean, vector database is opening up opportunity to work with a high-dimensional data. More the you're adding.
You need to have multi-dimensional that helps as well, right? Yeah.
So I mean, there's nothing wrong to experiment in my opinion. That's what I'm saying.
There's a lot of noise around vector DB. Like, what other choices of vector DB that people should look at?
The article is kind of the author kind of called out all three. There are two different types of vector databases right now is available. One is like fully managed or closed source, and then there's open source models kind of also coming in. The one that kind of mentioned here, like Pinecone is the one thing, is kind of closed source here. Milus is another thing which is from the Linux Foundation, which is an open source solution that you can run on your own. I think there's a Wait. I never used it, or I never tried it.
I also heard of single store, erstwhile MemSQL.
Mileworks and Pinecone are the two
Yeah.
things I hear about.
Single store again, earlier erstwhile MemSQL. That's also a product that at least I've seen the CMO talk about it being a vector DB.
Yeah. So it'll be interesting to see how this whole vector database landscape is coming in. Maybe there.
Yeah, I'm not sure how much of actual use cases I've seen on ground, but then I've discussed a lot on vector, and I think you before the call also gave me a good idea of use cases, etc.
Yeah, definitely. So for the readers, I'm actually experimenting indexing data engineering weekly in a vector index and we'll hopefully create an efficient search for you to find an article and understand more of a personalized way for you to handle.
Wonderful. I will ask questions around what's the best WAP pattern to be used, and you will have an answer on use
Totally.
Right.
It's actually a good way to kind of okay, you can ask a question. If you don't know, we're ready to do the consulting for you.
Yes, totally. Well, it's a good segue to the last topic of the day. There's not a week that goes without touching this. I think we just love talking data quality, mesh, products, all of that. So the last topic is interesting: data warehouse testing strategies for better data quality. If you're listening and if you want to comment, we would be happy to hear your feedback around how you are implementing your data warehouse testing strategies. There are hundreds of different approaches that I've seen, both traditional, automated, and all of that. How are you doing that today? We'd be happy to see that. So, what are the projects that you're implementing on that uses any patterns for testing? Are there any out-of-the-box tools that you use for testing?
I think one of the things that we are kind of trying it out, right? I think the articles that also talked about like shift left. How can we shift left as much as possible, and how do we making sure those data quality checks are, more around the operational efficiency of it. The number one challenge is that it is not the lack of availability of the framework. It is a lack of availability of understanding both the use cases, like how the consumers are actually using it,
Correct.
how early we can detect it. And it goes back to the WAP pattern, right? Like if you don't have any WAP pattern, you're just checking the data quality checks, your data is already produced and the consumer might start to consume before the systems are running here.
Correct.
Interestingly, what the authors kind of mentioning about, they're creating a test cases and they have the test cases config as a YAML file, and they have something called build kit, which is running a test pipeline, and then that runs data integrations. They also do some manual testing, and whenever they're committing the change, they actually creating a test pipeline and running it, which is kind of very interesting approach in my opinion.
But isn't this something that people do today? Because see, data warehouses, data lakes, all of that have existed for time immemorial right now. So there's a pattern that we have traditionally followed. How different is this approach based on whatever you have seen or observed from the past?
One of the things that I found out very very challenging, I want to understand a little more, because the test pipeline itself, in the past, I had the challenges building this kind of a test pipeline. The production pipeline moves very fast. You add new assets, new tables, and all sort of thing all the time. How do you kind of keep up with the test pipeline? Like, what would be the source of truth for the source? Is it a synthetic data generation? Is it a fake data generation? And how do we that your test will capture those things, and stuff like that. So it's talking about unit testing in terms of SQL, but I think the challenge is that at what data set it is running and how can we kind of do that one. I think that's one of the interesting aspect of it.
And towards the end, he speaks about observability, so which is again good and something that I was sharing with you as well, that people want automated features without having to write or open a piece of code. So observability, shifting left, and the capability to identify the problem, the drift of the data, etc. As in when the data flows till it reaches as a product in the hands of business users, I think you should be able to observe, monitor, and report feedback back to them as well. So I think the combination of that is an ideal way to test data warehouses. But then, as usual, contract first, WAP patterns, and all that ensure that your warehouse or your lakehouse holds clear and consistent data as well. So that's an important piece.
Yeah, in the observability side of it, I like the way that kind of clear classification of like this is a hard file, we should send a PDT alerts for that. Oh, this is a soft file, just inform into a Slack channel and say like, hey,
no SOS on a Sunday for one column that came null, right?
And some silent failures, like, oh yeah, there's something is failure, that's okay. Don't worry about bothering it and stuff like that.
Yeah, but then kudos to the team because they have been implementing and considering all of the different integration endpoints, and it's not showing the alerts or the monitoring just on a dashboard, right? So they're completing the loop as well. So that's very important.
Yeah, one of the things that I learned about is like this is a BigQuery test kit project. I have not explored that very much, but I really wanted to understand like what the BigQuery test kit is doing, and what are the advantages it is giving. Is it, I don't know whether it is directly, coding the production databases or creating your own data set for that. But this is something I'm curious to explore.
Yeah, totally. I think it's under open source license. I think a lot of the authors, on behalf of the authors, I strongly encourage you all to try it out. And it's I think it's a Python package which should be fairly simple, and there are examples on how you can use the package as well.
Yeah, awesome. So with this, this is quick. We conclude very quick now. So
I still believe it will be 25 minutes. So for the listeners, our plan is to shorten the session to 15 to 20 odd minutes. I'm not sure if we broke our record. But then, we would continue to give quality content, but then trying to make it very concise for people so that you can listen and get your things done and your work there, right? So,
all right, folks. See you.